Okay, let's integrate this thing by using the shell method. And I put up a video of what it looks like using the washer method, and this shell method is going to be just a lot easier because we're not going to have to invert functions to find out x values corresponding to y values. So we'll see how that all works out. So there's a little cylindrical shell. It has a thickness of dx. The edge of this shell is located at a value of x. And I'm just going to try to like map in all the dimensions of this thing. So this height of the shell, well, that's just 2x for that top y coordinate minus tangent x for the one below it. So I have 2x minus tangent x for that height. And then I need to get a circumference for this thing. I'm just going to put the radius in the diagram, and that's just x. Okay, so the next step is to cut and unroll my shell. So I'm going to slice it right there, and then I'm going to unroll it. And the little thickness, the little differential thickness there is just dx. And my height was 2x minus tangent x. And then my length of this slab is the circumference of the shell when it's rolled up. So that's 2 pi x. So I can write down my differential contribution to volume. And it's just length times width times height for this thing. So I end up with 2 pi x times the quantity 2x minus tangent x dx. And so now I'm ready to add these up by using an integral, but there's one detail that has to be worked out first. What's the intersection of that point? And for that we need a numerical approximation. So what I'm trying to solve is 2x equals tangent x. There's no analytical solution to this thing. So I'm going to use the find root function in wxMaxima. And that function is for approximating the value of x for which an expression is equal to 0. So I had to rewrite it this way. So let's toggle the maxima. I was actually just doing this for another problem, and it's in this top line of maxima. I said find root tangent x minus 2x as x goes from 1 to 1.5. So the important thing there is to choose an interval where you are approximating that you know there's a root, and look at the graph. I can tell there's an intersection between 1 and 1.5. So you have to put that in for maxima. And this thing turned out to be at 1.166. So x is approximately 1.166. All right, so now we're going to use an integral to add up all the dv's, all the way from x equals 0 to 1.166, 2 pi x times the quantity 2x minus tangent x dx. And this integral looks to me like the kind of thing you'd be able to do with integration by parts, but we already had to use an approximation anyway, so why don't we go ahead and just numerically approximate the integral. I just need to jot something down real quick. Okay. I'm trying to reduce my toggling. So we're going to integrate, but I'm just going to go ahead and tell Maxima I want to do a numerical integral, so that's quad QAG. I had 2 times pi, that's percent pi, times x multiplied by the quantity 2 times x minus tangent of x. So x goes from 0 to 1.166. Let's round it there. Oops. And I forgot to put in which algorithm to use. You could choose any number from 1 to 6. So I put in 1. and I get a volume of 1.787, or I could put in 1.788 as my rounded answer.